So let us go ahead with the today's agenda. Today is a day 4 of this particular course. As we know, this course duration is will be like 10 days, okay, 3 hours each, right? So this will be a day 4, and in this particular day we'll be talking about classification algorithms. Okay, what are the different classification algorithms we have, why to use classification algorithm. Then we'll be talking about the different classification algorithms. We will be starting with the logistic regression. Then we will be talking about the decision trees and random forest. Also, we also talk about the model evaluation matrices like the confusion matrices, classification report, as well as the ROC curve. Let's go ahead with the classification algorithm. As you know, guys, this course will be a around 80% practicals and 20% only theoretical. So you can be able to hands-on with the different algorithms of the machine learning, as well as the basics of Python, basics of R, MySQL, Tableau, and Python, uh, Power BI, right? So see, if we're talking about the machine learning, there are three main categories, right? First one, supervised learning. Then second one is unsupervised learning, and third one is going to be the reinforcement learning. And fourth one, we have a semi-supervised learning. So this is going to be hybrid type, right? Okay. So guys, for this particular session, we will be talking about the classification algorithm. As we know, there are three main types of the machine learning. First one is supervised. So in the supervised learning, we have the two different types, or you can solve the problem of in the supervised learning. And what are those problem? First one is regression, second one is classification. So as we know, we saw yesterday about the regression. So in the regression, okay, we are trying to build the model which can predict a numerical values, okay, like a the prediction of sales, right? Or a prediction of any price. We can say prediction of gold, prediction of temperature, prediction of you know we can talk about like a share market and all. Yeah, prediction of shares and all, right? So these are the different types we have in the reinforcement, sorry, in the supervised learning, we can say classification algorithms. Okay, if we're talking about okay this particular thing, okay, the classification algorithm. So here you can see that we are building the model which can predict a class. If we're talking about the the class, so we can say that the class is having the the category, different types of categories. Okay, let's say yes no category is there, then true false category is there. Like if we're talking about the another the example of the class, so we can say that you know the spam emails. In the emails, how many categories are there? The primary email, social email, okay. Then we have the you know the some kind of spam emails, okay, right? So you will find that the multiple categories in the email as well, right? So here as well, yes, in the gender, male and female categories, two categories are there which are main. Okay, so these are the things. So basically, if you're talking about the difference between the the classification and regression, so here, as you know, suppose if we have the data, so here you can see that our in the regression, our main goal is to predict a numerical values for our upcoming data set, or for just predict the future values, right? So here you can see that we have the data points with the we have the only data points, and here you can see that the main goal is to find out our upcoming data points, right? Let's say if we have the sales data, okay, till the March month, okay, and we wanted to predict the the sales of upcoming month, which is April, right? So by using previous months, we are trying to build the model which can predict the sales of upcoming month, right? So that we saw in the regression. Now what is in classification? So in the classification, you will see that, okay, there is binary class classification problem is there, there is multi-class classification problem. So if you see this particular plot, so in this particular plot, okay, if you see this particular plot, so here you can see that the two different colors in the data points, first one is red, second one is sorry, first one is green, second one is blue, right? So here you can see that there are two different colors, which means that there are two different classes in my data set. Yes, so I have to classify these two classes by using some mapping in between that. Okay, there is something, okay, or some conditions are there, or some mathematical concept is there. With the help of that, we can be able to classify that data into the two groups, okay, or into the two different classes, let's say the green class or let's say the blue class, right? So here you can see that, okay, we just build the model of classification, okay, like just don't imagine this thing in the not just the the two dimension. If we're talking about the let's say we have the data of the 10 columns, let's say at least 10 column we have. So we can't imagine the 10 dimension data, right? We up to 3 dimension of the data we can able to visualize, but we can't visualize the 10 dimension data, right? So here, okay, just to understand the concept of classification, okay, here this plot, from this plot you will understand what is classification. So here in the real life you will find that the few data points, okay, of the blues as well as the few only from the green also are here in this particular blue region, let's say. Also here you will find that the most of the data points are nothing but the green, and here also you will find that the most of the blue data points, okay, which means that, okay, like there is, like many times, okay, when you are dealing with uh, real time data, so at that time you will have to you know just understand that you will very rarely get the 100% accuracy, right? So that is the thing, okay. So these points, this this, out of this most of the green data points, you will find that the few blue data points, so those are nothing but your misclassification, right? In the same way here you will find that the green data points, which are few data points in the blue region, or most of the blue data points, right? So guys, let's understand about the classification algorithm in more detail. So that's why we will go further and we'll try to understand the different algorithms of classification, right? Okay, so let us talk about the linear regression versus logistic regression. Okay, so guys, as you know, what is linear regression? So here you will see that, okay, this right plot is going to be, let's say, linear regression, right? So here you can see that our data is different now. Our data is different, right? So this is my data. So basically you have, let's say, X and Y data. You have the two classes, right? So but your label is nothing but your Y data, right? As we discussed yesterday, or let me show you on the whiteboard so you will understand this thing. Now guys, as you know, if you are talking about the regression problem, so here you will see that the data set like this, either this or in any other, this is the upper trend data set that I am drawing. Okay, you may go, you may get a data set in the downward trend or the the non-linear pattern as well. So let's say this is my, this is my regression line and this is my data, right? And I have created a, regression line which is going in this particular in between these data points, which is exactly middle. Okay, now this is going to be the x coordinate, this is going to be the y coordinate, right? Okay, data, and this is how I build the model of the regression. Now let us see if we got the data like this. Okay, if we got the data like this, okay, this is my x coordinate, this is my y coordinate. Now you will see that, okay, you will get the data in the range of, let's say, starting from 0 to, let's say, 100. But here your target variable is not the continuous one, it is going to be the, let's say, discrete one. Okay, like let's say, let me assume this is, okay, here is my 0, okay, to show you, just to show you. Okay, and this is one value. Okay, and now we got the data like this, few values are over here in this particular region and few values are over here. Okay, as we know, we got the data like this, x values which are, okay, let's say 32, 22, okay, 41, 56, okay, then 78, okay, in between, 0 to 100, right? And your y data is like this, 0 1 1 0 0, right? So which means that if you plotted that data, so your data is not visually correct, you can say. So you can simply say, okay, if we write this particular data, so okay, this is my data over here in the regression type of problem. So again the same, okay, let's say 11 42, okay, then 53, I would say, then 24, like this. Okay, then 66, like this. And here you will find that the same kind of thing. Okay, 21 32, okay, 61, right? 25, okay, 78, like this. Okay, so here you will find that, okay, my y data is also somewhat continuous, you can say, right? So okay, and this also is continuous manner. Okay, let's say this is my, you know the, let's say, age, okay, column, and this is going to be the, let's say, any column. uh let's say the column is going to be the height, let's say. Okay, height column is there. Okay, so this is my age and this is my height, both are continuous one. So you will see the data like this, right? Now if we're talking about the classification one, you got the data like this, x data, right? The y data, okay, this is your y data, right? But here you will find that in your y data looks like this, 0 and 1 format only. There are only two classes, 0 and 1. Okay, so apparently, okay, after plotting scatter plot, so you will find that your data looks like this. Okay, few values over here and few values are over here. Now if you plot, okay, if you plotted the regression line, so you will see that your line looks like this, right? Your line looks like this. Okay, which is not the perfect equation for this particular problem, for this particular data, right? So for that you will have some kind of data or some kind of model like this, right? So you will have the data like this. Let me show you again over here. Okay, you want the model like this. Okay, so here in the PPT, if you okay, if you see, so here I'm trying to, okay, show you the same thing, right? I'm trying to show you the same thing. Understood? Okay, this is my regression problem. If we are using the regression on linear regression for this particular kind of data, so this won't work. So at that time you will have to use the logistic regression, right? So in the logistic regression, how we just created this particular line, okay, what are the different transformation we applied on this particular linear line, so we just able to convert this line into the S-shaped curve. This is somewhat like S-shaped curve, isn't it? Right? So this is my logistic regression, right? So in the name itself there is logistic, which means that I have used logist function over there, right? I have used logit function over there, right? So okay, let us understand what is exactly logistic regression is in the in the deep way, so you can be able to understand this thing, right? So this is going to be my sigmoid function. And what is this, guys? Okay, this is over here you can put your regression line or regression function. Let's say your function of x, which means that y equal to beta naught plus beta 1 x. Okay, this is the just the simple linear regression I am talking about. If you're talking about the multiple linear regression, so you can add the terms like this, beta 2 x2 up to so on beta n xn, right? So this is nothing but the function of x, isn't it? Is this a function of x? This is a linear combination of the your coefficients and your columns, the features which are there in your data. Okay, so that is nothing but it is a function of x, f of x, right? So you can use these over here. So 1.1 plus e raised to minus f of x. So this is going to be your sigmoid function. Okay, let's say you have the x like this. Okay, the 1, 2, 3, 4, 5, 6, so on. Okay, and you are using this sigmoid function, right? Sigmoid function is like this. Sigma of x is going to be the, you can use this formula, you can use this formula, you will get the values, some values, right? You will get some values and the plot for these values will look like this. The plot for this particular column, right? So that is the power of sigmoid function. Okay, now one more thing here over here is, okay, this sigmoid function is very much important. Okay, why I wrote this particular sigmoid function is because if you see that in our previous problem, the values for y are this 0 and 1, right? There are two values, okay, which are nothing but the 0 and 1. So if you wanted to find the probability of 1 and probability of 0, so at that time this probability has nothing but the, you can calculate by using the p of x, okay, which is equal to 1 divided by 1 plus e raised to minus f of x. Okay, and this will give you the, probability of class 1, right? And if, okay, and in short, okay, this is a probability of x. In short, I will write, okay, like this, x equal to 1, because here you will find this, but in the continuous manner you can't write this, okay, because it's a equal to sign, and in the continuous probability you will find that if you write this, so which means that its value will be 0. Okay, that's why I'm ignoring this thing. So that's why I have just written over this like this, right? So just, forget about this, because okay, this is not possible to write, okay, and the write the probability in the continuous manner like this. Okay, so here you can see that the 1 minus probability of x is going to be the probability of So you can simply use this. And what is this guys over here? This is just a simple linear regression function. Okay, let's say if I have, okay, let's say this is my problem, y and x problem we have. So I can simply write the model for this is going to be the beta naught plus beta 1, okay, x. This is simplest model I can say. Okay, I can use this particular model. Okay, I'll write this particular model over here and we'll get the model like this, okay, which is a S-shaped curve, right? So let's go over here, okay, and here you can see that, okay, now we got the values, okay, in terms of you will definitely get the values in terms of y, either y equal to 0 or y equal to 1, right? So this is the thing over here. So that is what I am trying to, show you over here, okay, either in this particular plots or in the whiteboard as well. Okay, if you see over here, okay, so here you can see that, okay, this is my linear regression. Okay, this is my linear regression. So if you see over here is, okay, if you see over here is, okay, the error you see, okay, is very less. Error is nothing but the distance between your original data points and your regression line, your predicted data points. But if you see over here is the distance now, okay, is very less as compared to this distance. If you plot the regression line over here, so you will find that for this particular data points, distance will be very high. Distance will be very high. So it can't predict the right output, right? It can't predict the right output because the aim of the regression model is to predict the continuous values or the continuous data. Okay, so you will find that it will definitely predict the values from, okay, if your data looks like this, so it will be able to predict the values from here, okay, like this. But if let's say if you build the regression model over here for this particular data, so you will get the values, let's say, okay, you will, let's say you will get the values from here. Okay, so you will find that the value of y is 1, but you will get the value from here of here, okay, which is not the correct value because the y values, okay, are just the two values, like the 0 and 1. Only two classes are there for y, right? So that is the problem with the regression model over here. Okay, that's why you will have to apply the sigmoid function over here and it can be able to predict the values either 0 and 1. Okay, and it can predict the values in the form of probability, in the form of probability. Okay, not the exact value, not 1 and not 0. So now let us go ahead and let's do some practical so you will understand in more details, right? Let's do some practical. Okay, I have shared you the the data, okay, which we will be using for this, but I guess not for the logistic regression. Okay, we will be using this particular data for the decision tree and the random forest. Okay, we will be using, okay, we just creating a dummy data for the logistic regression, right? So guys, let's create the dummy data. Okay, see guys, okay, uh, you know when we are dealing with this thing, okay, like when we are dealing with this thing, okay, why we, okay, let me ask you a question. Why we are creating the model? Why we are creating the model? Our aim is to predict the value, right? Either value in the form of numeric, okay, which means the continuous data, okay, either or in the form of classes, 0 1 class, right? So this is our main objective to build the model, right? So if our data is continuous, I'm talking about y, okay, if okay, I'm talking about y data, which means our main target column that we want to build the model, okay, which can predict our target column. Okay, so if we're talking about our y data, if our y data is continuous, right, if our y data is continuous, so we'll have to go with the regression algorithms, right? We'll have to go with the regression algorithms, right? And if your data, if your target data is the labels or the class data, so which means that only two values are there, only three values are there, only four values are there, which means that that data is the label data. Okay, that data is nothing but the label data. That's why you will have to use the classification algorithms, right? So here I'm talking about the error, because if you are using the regression methods or regression algorithm for the classified data, for the label data in the form of discrete, your target is discrete, so it's not possible. At that time you will get the very high error, right? So if you are using, okay, the regression over here, this is not suitable. If you are using the any other classification model, that will be suitable over here, right? So that is the thing. Okay, now guys, let us go ahead and talk about the logistic regression. So here I just rename this particular notebook as the classification algorithms, right? Classification algorithms. Okay, so as we know, first classification algorithm we will see, which is nothing but logistic regression. Okay, so guys, as we know, we have to import few libraries, right? So what are those libraries? As we know, first we'll start with the pandas as PD. Not understood your question. Why? What do you want to say? How do we get the title in the notebook? Okay, here you will find the the like acha, you want it. Okay, you want this kind of title. Okay, if you want this kind of title, you will have to convert your coding cell from the markdown cell, right? This is my coding cell. Okay, I just converted this coding cell in the markdown cell and I got the title, right? So this is how you can create the title. Okay, here what we are doing is we are, okay, importing the libraries, okay, which are important for our analysis, right? Then second we have the import numpy. It's not the comment, it's the code. So I'll have to go with the directly import numpy as np, right? Third library is going to be the import matplotlib dot pyplot as plt, right? And what will be the fourth one? For creating a classification model, we will have to import the fourth library, and in Python the most important library for the machine learning algorithms, which are nothing but the sklearn library. Okay, we will be using a stats model library for regression, okay, not for logistic regression. Yes, there is some confusion because of the over the name over here, which is regression, but you will find that logistic regression is the only regression algorithm, okay, which we will be using for the classification. Okay, this is not the, we can't solve the problem of regression by using logistic regression. Logistic regression is solving the problem of classification. Okay, and this is the only model which we can use for the the classification. It can do only one thing, classification, not the regression. We have a lot of multiple models, okay, which we can use it for the the classification as well as the regression one. Okay, as we will talk about those as well like the decision tree and the random forest. We will be okay understanding those model in the same session. Okay, so guys, okay, so that's why let's go and import sklearn dot linear models. Okay, dot linear model, and from here we will have to import the logistic regression. Okay, okay, logistic regression. Now guys, I just wanted to show you the some shortcut for this. Okay, pyplot is not the sub library, is the one module in the matplotlib. With the help of pyplot you will be able to draw the plots, okay, with the very less code, right? So that's why we will be using that particular matplotlib. Okay, dot pyplot. Now second thing is that if you see the if you wanted to import some particular, let's say, module, okay, or the model from the library, so what you can do is you can simply, if you wanted to sometimes like there are a lot of algorithms are there, lot of models are there, and we don't know, like the sometimes we just forget that particular model that we want to import in that particular case. So what we can do over here is, so sklearn, we can simply after dot, okay, like right, we want to go with the linear models as we know, so we can simply use the tab. Okay, if press the tab and you will see that, okay, see here I use the tab. Okay, and now here you can see that the so many all the modules which are there in the sklearn. See, are you able to see this? Just use the tab, right? So my aim is to import the linear model, right? Right, so here I'm gonna import. Okay, so this is the from, I guess, not the, okay, from sklearn dot linear model import, which one, the, again, logistic regression, like, right? So just press the tab over here and you will get the all the list, right? Logistic regression. So here you can see that you will be able to go with this thing, logistic regression, right? So this is how you can import the the model from the library. So sometimes you will find that the for the names logistic regression, you will find that the L is capital, R is capital. Okay, sometimes you are getting some error. Okay, let's say you just go with the lowercase. All this word is in the lowercase, and if you go with this thing, so it will definitely throw an error, right? And what will be the error? Logistic regression is not defined. Okay, in this particular library, right? This is not a regularization technique. Okay, this is a cross validation. If you wanted to explore your most of the data, so at that time you can use this. That is nothing but a sampling technique, one of the sampling technique, you can say, right? Cross validation, so which means that you will be getting, okay, let's say if you go with a cross validation 5, so which means that, okay, the model will automatically split your data into the 5 parts, right? And after that 5 parts, it will take the first 4 part into the train, okay, and last part into the test. So it will build the model by using the first 4 part and the predict the model by using the last part. In the same wise, it will again the revise your model, like it will take the first 3 and the last 1 part in the model for the training, and the fourth part as the testing. So likewise it will give you the 5 accuracies. Okay, so which accuracy is better? Okay, so you can, okay, if someone, okay, some give you the accuracy more than 90%, so you can simply take that instead of taking the any other samples, right? So that is the thing. So guys, let us go ahead with this, and after this, guys, see, okay, first thing is that, okay, we are, okay, using this particular thing, this two library. First library is to read the data and pre-processing it. Second library is to let's say create the arrays, numpy arrays. okay, and doing some statistical analysis, right? Then third library is for the data visualization, right? And fourth library is for the building the model, okay. And what else is remaining? After building the model, we need to evaluate the model, right? So for evaluating the model, okay, we need to import the evaluation matrices, right? So here we will be importing the evaluation matrices. Let's go with the sklearn, right? Dot, here you can see, okay, we will be talking about the matrix. We will be talking about the matrix, okay. I'll be showing you how you can do this thing, that's why, okay. Import sklearn dot matrix, okay, and from sklearn dot matrix import, not the capital, import, the first is nothing but the confusion matrix, you know, the confusion matrix you can see over here, right? And second one, I just wanted to import the classification report, right? So I can show you the, you know, that report, so which can define the how strong your model is by using the different evaluation matrices like accuracy, F1 score, precision, recall, right? So guys, let us go ahead and import these libraries. Let's go and execute this particular cell, okay. Let's run this cell. After this, let's go and import this particular they read the data, okay. Now here, instead of reading the data, what we are doing is we are simply creating a sample data, okay. We are creating a sample data which is very you know small data, I can say, okay. So what I can do is, okay, I'll be using the X data, okay. This is my the independent feature, I can say. And I'll be using the NumPy library for creating the data, and I'll be using the np.arrange the 10, which means that it will arrange the the 0, 1, 2 up to 9 values, okay. And I'll be reshaping it, okay. I'll be reshaping it into the -1 to 1, which means that, okay, if we simply go with the np.arrange 10, so you will get the data in row, okay. If you reshape it like this, so you will get the data in as the column, okay. So again, see here, npy has no attribute arrange, so I'll have to go with the arrange, okay, not the 2 hours, right? Then let's you know create a y data, right? np dot array, okay. And here you will see that I'll be adding the list of my classes, yeah. So here, as we know, we just created a 10 values in the X data. So here also I'll have to create the 10 values. So as we know, okay, here in the Y column, okay, Y column is nothing but my target column, okay. So here you will see that I'll be adding the 10 labels in, okay, either 0 and 1. So here you will see that the 4 labels are 0 and 6 labels are 1, okay. So this is the thing. So here you can see that if you go with the X, so this is my X, okay. This is my X. If you wanted to see the Y, this is my Y, right? This is my Y. Now you can see that, okay, it has a single singular list, you will see, and then comma, okay. So that is the that is why I did the reshape over here, okay. And here you will see that this is the single list, okay. And here inside the list you will see that the singular list, okay. So that is thing. Now here you can see that the second output, okay, second row you can see. So if you see that the probability of this, okay, 0.62 is greater than probability of 37, right? Probability of 37. So we can simply say that probability, okay, of this is greater than this. So which means that, okay, we got the class 0 as my prediction, right? So here, we'll have to, compare these two probabilities. There is no threshold value for this, right? We will have to compare this thing. Okay, if this probability is greater than this probability, then you can simply put prediction 0. Okay, and let's say, okay, here you can see that the last row. So okay, so this probability is less than this, because this probability is 0.97, so which means that this is the probability of class 1. So you can say that just make the prediction as class 1. What is the problem here? We are trying to solve the problem of two class classification, isn't it? Right? So if we have the two class classification, we'll get the probabilities only two. Okay, either for class 0 or for class 1. If we have the 4 class, you will get the 4 columns. If you have the 10 class, you will get the 10 columns, right? So how many columns you have, okay, how many classes you have in your problem, these many columns you will get, and you will have to compare this much, okay, this many probability. Let's say you have the 10 columns in your one row, so you will have to compare the 10 probabilities, and whichever probability is highest, you can make the prediction as that particular class, right? As that particular class. So that is the thing over here. Okay, so first column is referred to as a class 0 if the probability in that particular column is greater than the probability from this particular column 2. So which means that, okay, your class 0 is your correct prediction, right? So here, for the first three values, for the first three rows, you will see that probability value for, okay, in the first column is greater than the probability values in the second column, which means that you will get the first three values, the predicted values, as the class 0. Okay, and you will find that from the fourth row to the last row, you will find that, okay, the first column's probability value are the less than to the probability values in the second column, you will see. Okay, so you will get the probability, predicted values are nothing but the one for starting from, okay, for the row 4 to the last row, which means from the 4th position to the 10th position. Okay, there are multiple ways to find out the accuracy. So first thing, you can find out the accuracy like this. Okay, just the model dot score is nothing but the accuracy for this, your X data and your Y data, and you can see that your accuracy is going to be the 0.9. Like if we have the 4 classes, so at that time you will have to, you will have to check that particular row. Okay, because here we will be checking according to rows, not the how many columns are there. Let's say there are 4 classes. Now you will find that there will be 4 columns. Okay, if you go with the predict probability, and you will have to, go with the rows to understand this, to make the predictions about either 0, 1, 2 and 3, because there are 4 classes, right? So starting with 0, then 1 class, 2 class, 3 class, means total 4 class are there, right? So you will have to compare the 4 probabilities in the 4 columns in the first row first. Okay, and which probability is showing a, highest probability in between those 4 probability, that probability, okay, that class will be the predicted class, right? Okay, now this is my accuracy. Now second thing is that I just wanted to find out the confusion matrix. So this is my confusion matrix, right? So guys, let me make it markdown cell for this, and let me explain the confusion matrix over here. Okay, explanation of confusion matrix, right? So here you can see that in the confusion matrix, see, this is a 2 class classification problem, right? How many classes are there? Okay, only two classes, 0 and 1 class is there, right? So that's why you will get the confusion matrix as a 2 cross 2, right? As a 2 cross 2. So here you will see that, okay, let's say this is my the confusion matrix. Okay, this is very important, guys, because in the name itself you will see that the confusion name is there, so it's very confusing. Okay, so we'll have to, focus for this particular thing. Okay, so first thing is going to be the 3 value is there, right? First thing is going to be the 3 value is there. So we can say that, okay, the 3 value is nothing but the true negative. Okay, true negative. So in my confusion matrix you will see that the 3106, right? This is my confusion matrix. Okay, so this is my confusion matrix. 3106, right? Am I right? See, 3106 is there, right? So here you can see that, okay, usually in Python you will get the confusion matrix like this, true negative. Okay, why true negative? Because, okay, this is my confusion matrix. Okay, this is going to be the true negative, this is going to be the true positive. Okay, and here you will see that this is class 0, this is class 1, this is class 0, this is class 1. Okay, and this is going to be the, the incorrect prediction. So this is going to be the false positive and this is going to be the false negative. Okay, we'll be coming to this particular point. Okay, now let us talk about the true negative. Here we got the value as a true negative equal to 3. What does this mean? So for that, let me show you the original y data. Okay, my, okay, let's guys see, in my original y data, in my original target, you will find that the 40 and 61, sorry, in my y data you will find that the 40 and then 61 is there, right? And okay, let me write it over here. Okay, in my original y, the actual y, I can say actual y is there, you will find that the 0 0 0 0, 4 zeros and then 1 1 1 1 1 1, total 6 ones are there. But in the predicted y you will find that, okay, in the prediction you will find that only 3 zeros are here and then 7 1 are here. So let me go over here, okay, and write the 3 0, okay, and 1 2 3 4 5 6 7. Okay, so this is the case. Now let's compare it, let's compare the actual y values with the predicted one. Okay, let's compare this thing, right? So here in the true negative, okay, true negative means, okay, the class 0, positive means class 1. Now here you can see that in the actual y you will find that the first 3 zeros will be, okay, first 4 zeros, okay, first 4 values are 0, but here in the predicted you will find that only 3. So if you compare with the 3, so you will find that, okay, these 3 are the, out of 4 negative classes you will find that the only 3 correct predictions are here, right? So this value is the, we can say that the correct negative prediction. So guys, what about next? We have the false positive. Now here you can see that my false positive is 1. Okay, so here you can see that, okay, the next one, okay, total how many negative classes are here? 4 na. So 3 are the, okay, 3 got the correct prediction, right? But for the fourth one there is incorrect prediction, right? So we can say that this is going to be the incorrect negative prediction. Incorrect, negative prediction. Okay, so false positive, which means that, okay, this positive, okay, this one class here, you can see this one class is false. Okay, this one class is false, right? That's why false positive is that one is stands for positive, so that's why false positive is this. Okay, now what about next, false negative? Okay, you will find that the false negative value is 0, right? So which means that, okay, here you will find that, okay, actually we have the 6 positive classes value, right? But here, okay, we got the predicted values for all the 6 as the class 1, which means that this for all the positive classes you will find that the correct prediction, right? For all the 1 value you will get the predicted value as the 1, right? So that is nothing but the correct prediction for your positive class. But here we don't find any, incorrect prediction for our 1 class. That's why the value is 0 here over here, right? So here you can say incorrect negative class, positive class, right? Incorrect positive prediction. Okay, and lastly we have the true positive. The value for true positive is 6. So this is my true positive 6. So here you can find that, okay, the actual y values, the actual positive values are 6 values. Total ones, how many ones are there? 6 ones are there. Okay, and the how many predictions are there for ones? Okay, you will find that here 6 1 value are there, but the total 7 ones are there, because here one, okay, the extra one is for this particular 0 class, right? Okay, and the, the another 6 1 classes which are the predicted one, these are nothing but the correct prediction for the actual 1 classes. So that is why you will see that the 6, which is nothing but the true positive, right? So here you can see correct positive prediction. So in the name itself you will find that there is a confusion word is there. Okay, so don't try to be, don't confuse in that particular matrix. Okay, because there are only, okay, if we talk about the only 2 classes, so you will find that the confusion matrix, okay, of order 2 class 2. Okay, if there is a confusion matrix of, let's say, let's say we have the, okay, the 10 classes like this, so at that time our confusion matrix will be 10 cross 10, right? But here our case is only 2 classes are there, 0 and 1. So that's why our confusion matrix is 2 cross 2, and it is very simple to understand. Guys, understanding is very much important. Okay, only the understanding is there. Okay, if you know the what confusion matrix is, what these values are, okay, then it will be very easy, okay, to understand all about the confusion matrix, okay, and the upcoming evaluation matrix, which is nothing but the classification report, right? So in the classification report you will see that accuracy, F1 score, precision, and recall. Okay, so let us go and calculate that as well. Okay, so if you are, missing some concept, so because see, when I'm coding, so at that time, I'm just writing the code, nothing else. Okay, when I'm explaining something, so which means that, I'm not doing the coding at that time. Yes. Yes, absolutely. Sometimes it might be, difficult to, do the coding as well as, understand the explanation as well. But it will be very helpful for you, right? Like in the first, it will be, difficult to understand this, both the things here, understand the concept as well as do the coding, right? Yeah, the beginning part of the today's class is just the introduction about the what classification algorithms are and why we are using the classification algorithm. That's about it. So if you missed it, don't worry. Okay, the recordings will be there on YouTube, but I know why, but it is uh, generally it will take 2 to 3 days to upload the recordings on YouTube, but I don't know why they are not uploading. Definitely you will get the I'll discuss with my team and then get back with you. So I'll tell you what is what is the problem. So guys, uh, let us understand the classification report. Okay, this is the code of classification report. This is the one line code. You can see, okay, I got the classification report which is which is not in a proper format. Okay, so for that what I can do is I can simply use the print. Okay, now you can see. Okay, so here we got the how many things? We got the precision. Okay, we'll talk about that. What is precision? We'll talk about the recall. Okay, we'll also talk about the F1 score. We'll talk about the support. We'll talk about the accuracy. Okay, and these are the macro average. These are the weighted average. Okay, these are the not important thing I can say. Okay, we will be talking about the accuracy, the F1 score, precision, recall, and support. Okay, so the start with the simplest one, right? First, start with the simplest one. As we know, guys, what is support? Okay, so for that, how many data points are there in my data set? As we know, there are total 10 data points are here in my data set, right? So you will see that just 4 plus 6 equal to 10, right? So here you will see that, okay, in my Y, how many zeros are there? Okay, how many zeros are there? 4. How many ones are there? 6. So that's you will see over here. Okay. How many class 0 values are there? 4. How many class 1 values are there? 6. Okay. So this is the support. Support is nothing but the number of observation from the class 0 and the number of observation from the class 1. Understood this term? Support. Now let's go ahead with the accuracy. What is accuracy? Like I know guys, you all know about the accuracy. Okay, let us assume that all of you know about the accuracy. So what is accuracy?